Good morning, everybody. We are going to get started, so happy Halloween. We're really pleased to have everybody here today. I'm going to stop sharing my opening slide, but I did want to make sure everybody was having a good Halloween here in the U.S. Christian, do you want to go ahead and share your screen?
Absolutely. Give me a second, please. You just can let me know if you see my screen.
Yes, we can.
Yes. All right.
All right, so again, welcome to our October edition of the Pigment 101 series. We are extremely happy to have some guest speakers today who will enlighten us with their experience on pigments and dispersants, especially for the inkjet application area. However, this is not specifically unique to inkjet because the pigment and dispersant interface and interaction is ultimately important for all types of dispersion processes. So we are always pleased to work with our partners on the dispersant side to make sure that we can offer the best options for all of our customers to get the most out of the pigment in their formulations. So with that, I am happy to get started. This session is going to be being recorded, and all those in attendance today will receive the link to the recording as well as the PDF of the presentation. And if you have any questions, feel free to use the chat box, and we will address those questions at the end of the session. So with that, Christian, go ahead and go to the next slide. I'd just like to make a little bit of an introduction for our guest speakers. First, we have Dr. Christian Maus. He is with us in Sudarshan, he is the department head for Digital Inks at Sudarshan. So he helped us bring on board our Sudajet line of pigments. He's got extensive experience in dispersant and technical service, especially for inkjet applications at various companies. And his education, as his name implies, he has a PhD in chemistry. Our other speaker today, and we're happy to have him, is Niklas Kircher. He's joining us today from BIC Chemie. He is their lab manager for the inkjet inks application areas. He takes care of the technical service and development of all of the inkjet inks, and as you can imagine, works hand in hand with Christian on some of our activities that we have. His experience includes a lab chemist in the technical service lab for coatings and pigment concentrates. And he is a chemical engineer by education. And I knew I liked you when I saw that. So let us welcome our guest speakers today, and I will turn it over to Christian and Niklas for the remainder of the presentation, and I'll come back in at the end to help with any questions. Off to you.
All right. Thank you, Bonnie, for the nice introduction, and good morning, everybody in the United States or wherever you are. Good afternoon. This is the Pigment 101 Halloween edition. We're putting the horror live onto your screen, Niklas and me. And yeah, Bonnie, thank you for having us here. And Niklas, you want to say something, or I just continue?
I'll just continue.
All right. So today we speak about pigments and dispersants for digital inks. And first of all, I like to introduce our pigment line, which is dealing here with is the Sudajet line. Those are our dedicated pigments for digital inks. And during today's presentation, on the one or the other slide, you will see some of the products and test results of them. Just that you keep it in mind, Sudajet is the inkjet line or digital inks line of Sudarshan. And yeah, I'm also very happy and pleased that Niklas from BYK is today with me. And here's his introduction line about BYK.
Yeah, thanks, Christian, and also thanks to Bonnie for organizing this great event. Yeah, just some words regarding my company, BÜK. I do not want to bore you with all these numbers, but maybe I can give you some information that you do not know yet. For example, that BÜK is a family name. So we had a founder, Dr. Heinrich Bück, who founded the company 150 years ago. Yeah, what else can I tell you? Our sales are more or less evenly distributed, one third US, one third Asia, and one third Europe. Yeah,
And
and maybe
okay.
some words regarding our US subsidiaries. So our headquarter in the US is located in Wallingford, Connecticut. There's also our biggest production site in the US, but there are some more around the country. For example, in Gonzales, Texas, Louisville, in Kentucky, Earth City, and in Chester. And what is very important for us is technical service. So it's really never a problem to contact us if you have any questions or requests. Just give us a call or send a mail. That's really never a problem.
Right. Okay, so today our journey through inkjet inks will start here with the agenda. Let me quickly introduce you. We want to have a wild ride, through several topics. We'll start with inkjet inks, the market, and what we are really talking about today is industrial inkjet. And then we try to work our way down to pigments and dispersants, because that's those two ingredients are like the basic, or where you start with when you want to formulate an inkjet ink. So I will speak a little bit about what is so special about this here. And then I think very important also for you as customers that we present you how we are testing our pigments and dispersions once we made the dispersion, so that we can all speak the same language. We'll finalize with how it looks when it works out and some recommended products, and for sure at the end also some questions. And Niklas is going to talk a little bit about the inkjet market as he sees it now.
Yeah, I really love this slide because it shows how big the world of inkjet is. I mean, most people think about desktop printers when they hear about inkjet, but inkjet means so much more. The inkjet market is really is an extremely wide field, and especially in the field of industrial inkjet, there was and there still is a lot of development going on. As an example, look at the ceramics field. In the last 10 years, there was a complete shift from analog printing to digital printing. So almost 100% of the ceramic tiles in the world are printed digitally now. And something similar is happening in the textile field at the moment. Also, packaging is a really big field to growth. I think especially textile and packaging are the most interesting topics at the moment with the biggest growth potential. I mean, in the recent years, there was a lot of progress made regarding single pass inkjet printing. And there we have a quite nice example on the next slide to show you what we are talking about.
Exactly. It means this is from a YouTube source at this address, which I found. Just gives you an example that we are not longer talking about like a desktop printer where the printhead is moving from the right to the left, but with regards to industrial inkjet, a lot of things and developments have happened and improvements, and this is just it's just about the picture as you see how it works out now in inkjet inks. So it's not longer on like rolls like this, but it's all the printhead CMYK are next to build up next to each other, and there you see like the pictures or the tiles. It could be a tile or something else, the printed good. are now printed via the single pass printing method, which greatly increased the printing speed, hence made it available to industrial application. However, inkjet inks is an complex topic, and it needs to be correct down to every drop. And in the next slide, you will see what that means on the hands of example by two videos of yes, here you go, a drop watcher.
Yeah, I mean, at the end, inkjet means that you have billions and billions of very small droplets jetted through a printhead. And there's a quite nice tool to visualize that. That is the drop watcher. So these two videos were made in my lab. We see on the left-hand side an example which shows a bed jetting. You have tailing, means that the droplet is splitted into smaller droplets, which at the end leads to satellites. I mean, these smaller droplets have a different velocity, and that leads to print quality issues. On the right-hand side is a good example. I mean, also there, directly after jetting, you see a small tailing, but there's a very good recombination of the droplets. So this gives a very good print, very sharp droplets on the substrate. This is what we want. But that shows that it is really important to carefully formulate your ink. And as Christian said, the basis for good ink is always a perfect pigment stabilization.
Exactly. And some basic thoughts on the pigment stabilization and what might be so important or what might be so special about inkjet inks is displayed here in this slide. So other than in printing inks or in coating inks, in inkjet inks, you really need to create very small particle sizes. That's displayed here as comparison to a big particle. And then obviously what you did is you have increased the surface area of the pigment. And with the surface area, you have also increased the surface energy. So what a chemical system always wants is to minimize its energy. So the normal tendency of such stabilized pigments would be to re-aggregate and re-agglomerate to bigger particles like this. Hence, you need here really a perfect stabilization, and you will also need more of dispersants. Dispersant when you compare to coating application, for example. Hence here, in this example, the dispersant's purpose is to build in such a steric wall so that the recombination to bigger particles is inhibited, and hence the system is stabilized. And on the next slide, we will see what will happen if you are choosing the wrong dispersant. Niklas, please.
Yeah, I mean, one key parameter in inkjet is, of course, particle size. We need small particles because nozzle diameters are small. We are usually talking about the 50 values of maybe 100 to 150 nanometers. So if your pigment does not fit to the dispersant or the other way around, what can happen? We see in the first picture. Particle size distribution is, first of all, bimodal. You have a lot of bigger particles still in the dispersion. The total particle size is, of course, much too big. A better example is on the right-hand side. There we see a monomodal dispersion, which is somewhere in the inkjet compatible range, around 100 to 200 nanometers. And you have to imagine it's the same pigment, exactly the same pigment. It's the same grinding time, only the dispersant is different. At the end, that means that you can also optimize your grinding time or save grinding time and save grinding energy when you choose the right pigment dispersant combination. You usually have a certain particle size you would like to achieve, for example, 120 nanometers, and then you grind until you reach this particle size. And if you have a good pigment dispersant combination, then you can reach your target earlier. And that saves time and energy, which is, look at the energy costs at the moment. That's, of course, an important thing.
So obviously, if you would have to choose your fighter here, in this case, you would clearly go with this person B. And on the next slide, I would like to show you the influence on the optical appearance. So this is one of my favorite examples, which we did in our lab. What you see here is that's obviously a drawdown, 4 drawdowns here. And the drawdowns were made with the pigment red 146. The formulation of each of the drawdowns was exactly the same. It was the same grinding method, grinding time, same formulation. Only the dispersants were changed. So we just compared 4 different dispersants. And then look what you even can see with your eyes here, how the difference are in the optical appearance. So you got everything from a nice transparent bluish tone to a yellowish opaque tone. Same pigment, only different dispersants. That's something often people don't consider enough on this. And you can also see it here by the D90s and D99s, the huge differences here. So obviously the dispersant choice and pigment choice is really important. And on the next slide, Niklas will tell us a little bit what he will do, what he's doing when he develops the right dispersant for a pigment, as an example.
Yeah, I mean, to understand the interaction between a pigment and a dispersant, it's important to have a look on the pigment chemistry or the surface chemistry of the pigment. I mean, usually organic pigments have a quite low polar surface, which means they are quite difficult to wet, and it's also difficult for the dispersant to absorb at the surface because you always need functional groups to absorb there. That's the reason why many pigments are surface treated. You increase polarity of the surface, then it's easier to wet the surface, and it's also easier for the dispersant to absorb. A dispersant always has pigment affinity groups that are functional groups that will interact with functional groups in the pigment or on the pigment surface. Can be, for example, pi-pi interactions, means aromatic groups in the dispersant can interact with aromatic groups in the pigment. That can also be done via hydrogen bonding. If you, for example, look into data sheets of dispersants, you will often find amine and acid values. And these aminic groups can, of course, interact with acidic groups on the pigment surface and the other way around. And yeah, you can say the sum of all these interactions, that is how it is, or how the absorption on the surface is done. And the stronger this absorption, the better the stabilization effect is.
Exactly. Thank you. And on the next slide, we're going to show you how we are testing. Once we have prepared the dispersion with pigment and dispersants, there are several procedures how we test them in our laboratory. And it happened that Niklas and me, we are more or less exactly doing the same, and that's presented here. Niklas?
I mean, at the end, there are, I would say, 3 main parameters in inkjet. That is viscosity, that is particle size, and that is stability. Of course, there are many more parameters, but this is the basis. And viscosity should be as low as possible. Viscosity can also be used to judge the quality of the pigment dispersion. Lower viscosity of the pigment dispersion means better stabilization. Viscosity should be Newtonian. There should be no yield value. And yeah, I mean, you can use, for example, a Brookfield or an Anton Paar to check that. Particle size is usually measured via DLS, dynamic light scattering. Yeah, we have seen examples before. Particle size should be low, should be monomodal. There should be no big particles inside that could clog the nozzles. And that is also something that you can check with a filter test. Filtration is also very important. So every ink is filtered during production. And there are also different possibilities how to do that. There are simple syringe filters that you can use. You can also use bigger filtration equipment like we can see on this picture. So you create a vacuum and put a defined amount of ink in the filter and measure the time that is needed to go through the filter. There are different filters available, for example, glass fiber filters or nitrocellulose filters. And then you measure the time. Last point on this slide is long-term stability. That's, of course, also very important. That is usually done at elevated temperatures. For example, 4 weeks, 60 degrees C, or 2 weeks, 70. So everybody's doing that a bit different. After that, you should check parameters like viscosity, particle size, and filtrability again. And there should be no difference, of course. And another hint from my side, sometimes also stability at lower temperatures is quite critical. You should also check that. So you can put a sample in a fridge, for example, and check what happens. So sometimes, for example, you have crystallization tendencies in the ink, and this is, of course, also a critical point.
That's only one part of it. That are the basics, but for sure you like to see also the optical properties. You will have to match a certain color shade, a certain transparency, a certain color strength. And as discussed before, that can be also depending on the dispersant used, not only the pigment. That's typically something you check. Then you created the pigment dispersion only, which means in the formulation you find pigment dispersant, maybe a defoamer, water, and a little bit of glycol. But sooner or later you will have to formulate a complete ink. So you will have to use a letdown. And here you have to check the compatibility, that you ensure good deflocculation and the stabilization in the ink. The ink itself must have a good resolubility to prevent latency problems during inkjet printing, so that if the printer is stopping for a certain period of time and it start again, it might happen if the ink hasn't a good resolubility, that you will have some misfiring droplets at the beginning of the jetting procedure. Hence, the complete system has to have a good resolubility. That's something you can test. And last but not least, and that it's very important and it's a part of our daily life, is the regulatory compliances, which is depending on the end application you want to use it. The ink for that can include indirect, direct food contact, textile regulations can be and have to be considered. Swiss ordinance, FDA, Ökotex, that's some example. So there's a whole procedure going on when we test our dispersions made of pigment and dispersant. And next slide is, here we come already to our products. These are the pigments for inkjet we are offering you. On the color circle, you will see quite a more or less complete portfolio, which we built up over the last years to dedicate to this market with the known pigments, mostly pigment red 122 as the magenta. Then we have a yellow 74 as a yellow, 15.3 blue, green 7. This is all available. And also, as we are here with BYK, we can give some dedicated recommendations utilizing their dispersants. That is done exemplary on the next slide.
Right.
And
So
Niklas can maybe tell a little bit some secrets about his dispersants in this occasion.
right. So on this slide, we see combinations that we know work well. This is now all related to aqueous inkjet. Of course, we have a lot of other combinations for solvent-based systems and also UV systems. Yeah, I can tell you something about the dispersants mentioned here. We have the so-called Bigjet grades that are additives that were especially developed for the use in inkjet inks. Means especially good viscosity reduction, especially good particle size reduction, and especially good stability. We are talking here about comp copolymers, SMA-based, so styrene, malic acid anhydride. Yeah, is the backbone of the polymer. This polymer has pigment affinity groups. We usually use aminic pigment affinity groups, sometimes also quaternary amines. And at the same time, this backbone is modified by a polyether side chains that give the steric stabilization. That means the backbone will adsorb at the particle surface, and the polyether chains give the steric stabilization. The difference between these products is mainly in the pigment affinity part. We have different possibilities to play around there. Yeah, another difference is in the molecular weight. You can make these polymers shorter or longer, and of course also that has an influence on the final results.
All right. So I think we are on time, and one more slide. And if all of this is coming together and you decide, well, I'm going to test all of this, you can write me an email. You can write Niklas an email. In case you write me an email, I can provide you with detailed results. This is just a screenshot of how it could look like in the presentation. That's from a recent work we did on textile inkjet. We tested our pigment green 7 here. You see here the pigments we tested and some drawdowns here on cotton fabric. And you will also get detailed results on viscosity. Initial after several weeks, up to 4 weeks, particle size distribution, D50, D90. Where you will find we can provide you with filtration test results before and after storage stability. So we have a very large database with a lot of dispersants, also with some resins tested in the ink. So that's all available with coloristic, viscosity, particle size, like what I said before. And I think we're coming to the end of the presentation. Hope you have enjoyed, and maybe there are some questions. Oops, I'm sorry, you can still see my screen, right? And Bonnie, you want to take over?
Sure. Yeah. So we did get one question early on. The question is the LED ink, LED inkjet inks I have will have a thin, clear layer on top during storage testing, like 55 degrees C in a test tube for 1 week. How to fix it?
Can I?
Okay.
LED means LED cured UV inkjet inks, right?
I'm guessing this is true.
Yeah. Yeah. Yeah, I think
they have a thin clear. Oh, okay. Yeah, you want to start?
Yeah, I think there is not an easy solution. But I could imagine that maybe this is related somehow to pigment stabilization. Yeah? So that would be the first thing I would check. If there everything is okay, maybe you can optimize a bit, and yeah, then maybe the problem is already solved.
Okay. And I will connect. And I will connect the sender of this as well, so that you can have further conversation if needed. So there's another.
Bonnie,
Okay, go ahead.
one more hint. It's LED inkjet ink, so it's UV curable, and he has a thin clear layer on top. Could also be a start of a polymerization, maybe. That means I would store it in a brown bottle, first of all, and polymerization inhibitors could be maybe used. That could also be something here, to use several inhibitors. Normally, you don't want to use them, because if they inhibited the polymerization during the storage, they will also do it during the printing inks. But then maybe some fine adjustment needs to be done.
Good. So another question was, is what is the typical pigment load in inkjet?
That's depending. It's in the dispersion, you can load it up as much as you want in order to get a, but you need a free flowing ink. Typically, people using around 20% pigment loading in a pigment dispersion, and in a final inkjet ink, you'll find pigment loading of 3 to 5%, I would say. 5 is already much. I think around 3% is the typical amount in an inkjet ink.
It's a bit, I think, pigment depending or color depending.
Yeah, that also.
For cyan, you need a bit less. For yellow, a bit more in the final ink.
Right. In there. So I have a question for the team here. In the recommendation slide, you had two examples of two different Pigment Red 122s, and each of those had a better dispersant that was recommended for that one. And in all of our Pigment webinars, we always stress the importance of that match, to be able to do that, and that each finishing step, we always talk about how, from a pigment manufacturing perspective, we have many options for finishing, whether it's chemical related or mechanical related. And I just wanted to make more of a comment that in this particular case, although the pigment chemistry itself is Pigment Red 122, the finishing techniques that were put upon these two different products resulted in a different optimal dispersant. And so one slide that I always have in my presentations is this balance of matching the pigment and the other ingredients to get the optimal properties in there. The other comment that I want to make is that we are pigment manufacturing, so we make pigments in coatings grades, plastics grades, and ink grades, and everything in between. And during your presentation and some of the examples that I've seen, we see examples that are from all categories of pigment grades. So in your green example, one was a coatings grade, one was a plastics grade. In some of your other examples, we've seen all types of grades as well in there. So again, one of my favorite statements is all the pigments will work. All the grades will work. They will just work differently, and there might be some advantages that we can take advantage of in the formulations. We just need to explore those and match up to the proper formulation. So that was long. Really wasn't a question. It was more of a comment to add to your presentation. A couple of other questions came in. What is the difference between the normal pigment line and inkjet line from solely pigment point of view? Is it the particle size?
Yeah, for instance, it is the particle size, the suitability in the specific end application, like waterborne inkjet. Then we have something for solvent-borne inkjet, UV inkjet. It needs to be not only a small, but also a narrow particle size. It needs to be stable for a long period of time. Those is all included in the Sudarshan line in this case. Yeah.
Great.
And I think here's a question for Niklas. Do you have a hydrophobic dispersant?
Okay. For water-based inks, I guess. I mean, if you use a dispersant in a water-based ink, you need something which is water soluble. That's clear. Otherwise, it cannot work. But of course, there are differences in hydrophobicity or polarity. There are dispersants that are more polar. There are other dispersants there that are less polar. Okay, it's for UV, I see.
Yes.
Yes, that is of course also a topic in UV. Our Bigjet 9151 and 52 are quite polar structures, so there you sometimes have an influence on water resistance. We have the Disperbig 2030, which is less polar. That would be my first recommendation here, or the Disperbig 168, which is based on a polyester modification. And also this one is more hydrophobic.
Very good. Okay, the next question is, I am making solvent inks with the use of BIC 9131 pigment, but after grinding we find some black particles in the bottom. So what do I do?
Change the
Black
pigment
particles.
supplier. Well, as long as you are not grinding a carbon black, I guess that's so where can they come from? The BIC 9139 will surely not have any black particles in there. What can it be in the pigment? I mean, that's just guessing here, right? We can't know, but will it change? Will it change when you change the pigment of another vendor or something like that? Does it still occur? That's something I would first try to find out this. Yeah, so change something in the formulation and observe if it is still happening.
Okay, and we can follow up on that one as well. The next one is kind of interesting to me. Any recommendations for coatings for an OEM, nano dispersion and UV compatible? I'm guessing that's more for you, Niklas.
I mean, in principle, all the products mentioned for inkjet inks can, of course, also be used in other applications. Especially requirements in OEM coatings are also quite high. Maybe not as high as in inkjet inks, but also quite high. So often similar products or the same dispersants are used there. We have many more. I think this is now related to UV systems. For example, Disperbig 168 is also suitable there. Disperbig 2013 is another good choice, or the Disperbig 2030 that I also mentioned with better water resistance might be another choice here.
Very good.
For me, the best, one of my favorite go-to guys in UV, and I'm assuming it is UV based on the question, is for me Disperbig 2013 works nearly with everything, so I can also recommend this.
Very good. Another question came in is it possible for a dispersion to induce metamerism?
Yes. Ooh.
Well, that's a good one.
It's a good one.
I mean,
so I'll add a comment to that one. This is a very interesting question. I would say that in from a metamer perspective, what you're doing is you're changing the light reflectance of the coating or the ink or of the pigment in this case. If so, as far as inducing metamerism, I would say if you're changing the particle size or size, the size distribution significantly from where it was intended to be, that can potentially induce metamerism, because you're changing the amount and the intensity of the reflected light and transmitted light, so that it could potentially induce metamerism. With different light sources having different amounts of energy towards that particular particle, that could potentially show that. But I've not seen it, not looked for it, to be honest with you. I think I can see Christian's mind going there as a potential thing to look at as he's going forward in doing with the effort that they're doing with different kinds of dispersants and their impact on pigments. Obviously, they're taking a look at particle size and distributions, so that might be something that they could potentially keep an eye on, just as from a curiosity perspective, if nothing more. All right, we've got a couple of one more question here. What problem occurs if pigment grinding more in a bead mill?
That means too much. You over grind it, you will lose your color. I guess that's the meaning of the question.
Yeah.
So how you I mean, best is just to avoid it, and how you would do it is when you are grinding in your bead mill, how to control grinding time of particle is not available. Oh, that is maybe that's related to the first one. That is really difficult. In terms of inkjet inks, it would be difficult. So because maybe to summarize, you would normally grind, you have your passes or you grind it in a flow, and from time to time you will take samples and measure the particle size in the malvern. And once you see no significant improvement in the particle size, you can consider the milling is done. Now, if you now have if particle size analyzer is not available, well, you could work with color strength, right? So you could take a sample, you could do a white tint like the coating guys do it, and then you do the drawdown and measure the color strength, and then you see how the color strength is developing. And then after a certain time on the grinding mill, you will find out that the color strength will flatten at a certain point and will not longer increase. That will be at least a very good sign you are where you want to be. That is my suggestion here.
Or you are where the formulation and the dispersion process allows you to be in there. So that's the case there. Going back to the one question with the bead mill.
Good.
Part of that question is addressed to do you have the right if your pigment loading is too high, your viscosity could be up there and interfering with your actual dispersion efficiency. The overall viscosity of the system will hinder the dispersion process. So there are many, both formulation as well as dispersion process parameters that all have to be balanced to get the optimal dispersion in there. So it's not a one answer question or a one parameter question. They each have to be balanced to get the best performance from that dispersion.
And we have also a guest here with the name Saurab. He just mentioned it might be also analyzed by the filter ability test. That is absolutely true. Like the filter test, which we just did, you will receive a so-called filter index. So you're taking the time of the first filtration and the third filtration divided, and you get an index. And also this can be used when to find out when the milling is done here. Yeah, good point.
Yeah, good idea.
So Niklas, it's already past 4 o'clock, right? And
Yeah, time to start
tomorrow,
the Halloween party, huh?
Tomorrow is Halloween. No, today is Halloween, but tomorrow we have state holiday. It's past 4 o'clock. So what should we do?
I'm thirsty.
There you
Yeah.
go.
I mean,
Cheers.
it's the end of our
Cheers.
working day, yeah?
There you go.
But you guys have to work. But feel free to ask some more questions.
Right.
Cheers, Christian.
Well, I really like to thank Christian and Niklas for their time. I think this was a great discussion, and thank everybody else for their questions. It was great to have this interaction. And at this point, I'll close the webinar, and any of the additional questions that come in, we'll make sure that they get to Christian and Niklas. And for that, we'd like to say thank you for joining us. This will be our last webinar for the season. We'll take November and December off for the holiday times. So everybody enjoy your holidays as they come along, and we will get back on track in January of the new year with our webinar series. So look for those, and we'd like to say thank you and goodbye, and have a great rest of your day, and enjoy your holiday over there in Germany.
Thank you very much.
Take care, everybody.
Thank you for joining,
Thanks, everybody.
guys.
Bye-bye.